All right, hey again, Honors Chemistry. Here is another example of walking through interpreting and reading and then calculating percent yield. So let's read the question. It says, determine the mass of carbon dioxide one could expect to form. So in reading that question, it says one would expect to form. That must mean that carbon dioxide is a product or one of the products. So I'm trying to figure out how much carbon dioxide is formed. And then eventually it says the percent yield and the percent yield for the reaction between excess CH4 and 11.6 grams of O2. So it's saying for the reaction between CH4 and O2. That means that CH4 and O2 are reacting. They are my reactants. So I'm going to write them down. CH4 plus O2. If 5.38 grams of carbon dioxide gas is produced along with some water vapor. So I know that CO2 is a product, and it says water vapor, so that's H2O. How did I write CO2? Carbon dioxide. Carbon is 1, dioxide is 2 oxygens. All right, and then let me just make sure this is balanced. Right now I have 4 H's here, but only 2 here. You could do the drawing of the particle diagram method to make sure that you have the right number. If I put a big 2 here, I will have 4 H's, 4 H's. And then I'll have 4 oxygens right now, 2 O's here, 2 O's here. If I put a big 2 here, then we will be in business and balanced. So I have 1 carbon, 4 hydrogens, 2 times H2 is 4 hydrogens, 4 oxygens from the 2O2, 2 and 2O is 4 oxygens, so we're balanced. I'll begin to write my BCA. And it's nice that in the question, it is telling me that it's an excess. If it doesn't give you the amount of a reactant, you're just going to assume it's an excess. But it says, determine the mass of carbon dioxide one could expect to form. So I need to figure out this. Right? It's looking for carbon dioxide. For the reaction between excess CH4, so it tells you that this is an excess. That's nice. And 11.6 grams of O2. Remember, I always have to convert my grams to moles. So 11.6 grams divided by 32, 0.3625 moles. If you didn't know how I got that number, look in other videos, okay? And since it gave me this amount, all of it's going to be used up. 625, sorry. 625. 0.3625 moles, okay? Now, for my mole-to-mole ratio of oxygen to carbon dioxide, which is what we really care about, it's a 2-to-1 ratio. If you want to see the dimensional analysis, I'll write 0.3625 moles of O2 times there is 1 mole of CO2 for every 2 moles of O2. I'm writing my dimensional analysis where for the want over have, it's got to be mole ratio. So my want is how much CO2, and I get the 1 from the balanced chemical equation. The have is the 2 moles of O2. That's from the balanced chemical equation. And this is how much I have or given to me. So 0.3625 times 1 divided by 2. And so I should get 0.18, I'm going to say 181 moles. I'm just rounded to 3 sig figs. So this should be plus 0.181 moles. And I should get 0.181 moles of CO2. Okay? Now, if I wanted to do more math, right, this is a 2-to-2 ratio, just to kind of simply let you know, just in case if I want to complete the BCA table, I should have no products in the beginning of the reaction in the B. In the change, this is a 2-to-2 mole ratio between O2 and water, which is the same thing as saying 1-to-1. 2-to-2 is the same as 1-to-1. So because 2-to-2 is the same as 1-to-1, I could just say that they are equal. So if I have 0.3625 moles of O2, I should have 0.3625 moles of H2O. Just in case that was a question. It's not asked, but this is how I would complete it, but I don't need it. And then if I want to figure out how much CH4, this is a 2-to-1 ratio, kind of like my CO2 was a 2-to-1 ratio. So this should be 0.08181 moles of CH4 that's used, but I still have excess. Anyway, so I figured out that I have 0.18 moles of CO2, and I have to convert that to grams. So the molar mass is 44 grams per mole, as mentioned in a previous question. So 0.181 times 44, and I get 7.96 grams of CO2. this is my theoretical yield. Using all of my reactant, the amount of product that could possibly be received is going to be my theoretical yield. So I didn't use this 5.38 grams anywhere. All I used was the amount of reactant given to me, which was 11.6 grams of O2. And so this is my theoretical. And then it says if 5.38 grams of carbon dioxide is produced, right? This is my actual yield. Right? So if it's telling me that, oh, I produced this stuff, that means I actually got it. So if I'm going to do percent yield, it's going to be 5.38 grams, what I actually got, over 7.96 grams times 100. So 5.38 divided by 7.96 times 100, and I'm going to get about 68% yield. Okay, so there is another example of calculating percent yield.